this off, we're just going to review lesson 5, graphing on a coordinate grid. Kind of very, not, I don't want to say easy, but like some basic stuff. We're just kind of moving on. We're introducing graphing and patterning today. That's really what the lesson is about. So this is just a review. So remember that what you have a grid. Right? We talked about a Cartesian plane. Right? You have an x coordinate. Right? That is on the horizontal axis right here. Oop. And you have the y coordinate on the vertical axis right here. Right? You kind of get that. And so these are two perpendicular lines. They intersect at 0. 0 is our origin. Right? So right here in the middle, that's our 0. That is our origin. And so all positions are described from the origin. That's the source. So you get these coordinates, or ordered pairs, and your coordinates are going to be where is it in reference to the middle, the direct middle, the intersection of the lines. So for this, we start off with, these are our coordinates, 5 and 3. The first number, let's highlight in green, the first number, right, tells you how far to move right. The second number tells you how far to move up. Second number. Now if it was a negative number, it would tell you to move down, but we don't have to worry about that, right? So what that means is you start at 0, you move 5 to the right, 3 up, and this is where you plot your A. All right? That is your coordinate. It is two coordinates. It's called the ordered pair. Don't know. So this is part of our practice. So basically, this is kind of just like now identifying it, right? So let's start with A. A has the first, from 0, from the origin, how far right do we go? We go 0, right? So that since we move 0 to the right, our first number is going to be a 0. Now how far up are we going? I'm going to go 1, 2, 3, 4, 5, 6, 7. So 0 to the right, 7 up. That means D here. This is going to be A. Okay, then we can continue. For B, we're moving 1 to the right. So B is going to be 1 to the right and 5 up. This will be B right here. Right? C will be 7 to the right, and it doesn't go up at all from that 0. So we have no up. Oh, I got that backwards. I know Yazin's going to call me out on that. This one should be A, and this one should be C. Sorry about that. Okay, and then D, we're moving 5 to the right, and we're moving 1 up. So D is going to be the only one left over. And that's really what we have to know, right? Is how to plot and how to recognize where plots fall. That's from lesson 5. That's really what we have to know from from lesson 5. Is how to recognize where plots are, and then given a table, how to put plots on. We also talked quickly just about scale, right? When the numbers of an ordered pair are large, we use a scale. So for instance, all of these in actuality, right? How many lines are there? We can count how many lines there are. There are 8 lines, right? This is actually number 8, and this is actually number 1. But what we're saying is one line equals 5, and it's a ratio, right? A 1 to 5 ratio, and that's what a scale is. So we say that one line equals 5. So we can start plotting things with bigger points, right? We can actually plot B, 10, and 30 on a limited graph. We don't have to have a huge graph. What we're going to talk about today is drawing the graph of a pattern. All right, we're focusing back on a pattern. And we're going to have to focus a lot on this idea of moving spaces to the right and moving spaces up. All right? If this video isn't sufficient enough, there is an extra video right here. Just click on it. It will talk to you a little bit more. It's about a 3-minute video. So first of all, different ways we can represent patterns, right? So here we have 3 different ways we can represent visually a pattern. So so far we've been using variables, we've been using numbers. This is how we do it with visuals. Okay? So here we have some images. All right? We have tiles. Here we have a table. Okay, they represent the exact same thing. The figure number is going to be the first coordinate, so I'm going to highlight that. So this is figure 1. This is going to be on your table your very first input value. All right, figure 2, notice, will be your second input value. The number of tiles is going to be your second coordinate or your output value. So we can count them. We have 3 tiles here, which means that we should have 3 underneath the 1, right? For the 2, we have 5 tiles. So for figure 2, we should have 5. And so on and so forth. And once again, we can write this as an ordered pair. Same thing here. Okay? This is just changing my color. This is figure 1. So on a table, this would be input value number 1, right? So you could even draw a quick little thing here. This would be a 1, right? So this would be our input or our x, right? This would be our output or our y. This is figure 1, 2, 3. And then we just need to count for our output the tiles. We have 3 here, we have 5 here, and we have 1, 2, 3, 4, 5, 6, 7 here. So we'd go 1 and 3, 5, 7, 1, 2, 3. Okay, so all we're showing you is that the figure number is the first coordinate, right? So the figure number here is the first coordinate. I'm just going to draw a little arrow to here, right? The second coordinate, or the output, or the y value, is going to be the number of tiles in this image. Okay? If you have any questions about that, comment on the Zoom chat, and let's talk about it right now, because I think this is kind of just the very first thing. Once you get this, the rest of today is easy. So from that column, from this column here, I'm just going to do a little from this, because that's what we're focusing on. From there, we can draw a table. First, you're going to draw, and then you're going to label the coordinates. Okay, so they already have the plot points written down here. So you have your 1, 2, 3, 4, 5. Those 1, 2, 3, 4, 5, we got them from the numbers of figures. We have 5 figures, so we're going to have 5 plot points. Okay? And then here, 3, 5, 7, and 9, and 11, those are going to be how many, right? How many tiles were in the actual drawing. So then what we do is we plot them. So first we go to the right 1, and then we're going to go up 3. So right 1, up 3. Okay? And we can label that, if we want, we can label that figure 1. You could label it F1 if labeling it helps you. So that's the very first drawing. This will be F2. This will be F3. I don't want to cover this up. Okay, because it's important. Okay, so they labeled the axis with the column heading. So you notice this here, they also labeled the x-axis. They explained how this is the figure number. And then this is the number of tiles. So you know exactly what you're plotting. This becomes really important in science, right? In science, when you're doing an experiment, like you can say, how fast does a water balloon fall from a certain height? Okay, so when you have it at different heights, one of those will be your how fast it falls, and the other one would be your height. So things like that becomes very important. So from this graph, what we can see is that each time the figure number increases by 1, so it increases by 1, so we're going this way, increases by 1, right? We move, sorry, I lost my track. Every time it increases by 1, the number of tiles increase by 2. So every time we go right 1, we also go up 2. Okay? Every time we go right 1, we go up 2. And this is I'm just doing a little plus, and this is our pattern. All right, this is the rule that relates it. To get from one point to the next, we move to the right, move 1 to the right, and up 2. So again, we can get an input-output machine, and we just kind of work backwards. For this one, we started with this chart. Well, actually, we started with the images, the pictures. Then we plotted them using these rules I've highlighted, right? And then we put them on a graph. On this one, we're starting with a table, and then we can plot them. Okay, so I can give you, and this is probably what you're going to see on your test. Sorry, just my colors are hot. At the spinning wheel of death. Uh-oh. I don't know if you can see that. It said it was saving. Okay, we can graph the relationship shown on an input-output machine. So remember, this is our x. This is our y. Okay, so what this tells us is we need to plot the coordinates 1, 5. Okay, this will be 2, 8. So what they did here is they plotted these points and they noticed the relationship. Every time it moves over 1, it goes up 3. Okay, so if you notice here, there's a little bit of a halfway point, right? This doesn't fall directly, and so this is how we do when we scale. Okay, so this falls right in the middle. So because it falls in the middle of 4 and 5, 4 and 6, it's going to be a 5. Okay, so it still goes over. So this is a normal scaling, so we know it's going over 1, but then it's increasing 1, 2, and 3, right? So once again, this would be where it started. We go 1, and then when we go to the half, we go to the 7, and then to the 8. So we started at 5, we went all the way up to the 8, so we're increasing by 3. I realized that was pretty confusing. I'm going to re-explain that. Okay? We started this dot right here. This dot here, I don't know if you can see it. The first one, we're going to call it A. Alright, it starts on the 5 on the y-axis because it's at that halfway mark. That means every halfway mark, right, even here, there's another number there. So when we go up, even though it looks like it's going up 1.5, it's actually, because of scaling, it's going up 3. Okay, so we started at this dot on 5, we go past the 6, past the 7, up to the 8. That means we've passed 3 numbers, so the output increases by 3. We should notice the relationship that the input is increasing by 1 and the output is increasing by 3. Right, 3, 1. The exact same thing here. This is increasing by 1 because the x is the input, and this is increasing by 3. Okay, so again, we're graphing the relationship. So I forgot to add the title. It doesn't really matter. For here, this is an example of one of the questions you have on your homework. So you're going to record each pattern in a table and then draw a graph to represent the pattern. So first of all, right, we need to remember that this is figure 1, this is figure 2, this is figure 3, and this is figure 4. Okay, those are our figures. That means, remember, whatever the figure value is, that becomes our output. So we have our input, 2, 3, and 4, because we have 4 different patterns, figures, visuals, whatever you want to call them. Our output number, our y, is going to be the number of pieces. Okay, so we have to count them. So we have 3, we have 7, I believe. We have 3, 6, 7. We have 10. Well, that's not right. I miscounted here. 3. No, that's right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 8. That's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, that's where I made a mistake. The first one is definitely not 3. So as you noticed in this video even, I make mistakes sometimes. So that's the most important thing in math, is just you make your mistakes and you just learn from them. All right, so these values that we just wrote down, right, number of tiles will be our output. 4, 7, 10, and 13. From there, we have our coordinates. Okay, so remember, this will become 1, 4. So starting at the 4, so we're starting at the 0, we're going to move over 1 and up 4, so we're going to plot right here. Okay, this is going to be 2, 7. I won't do this for all of them, but I'm just trying to help. So you're at the 2, you move 2 to the right, right? 1, 2 to the right, and up 7, right there. 3 and 10, and 4, and I had to make a new one because this one that I found wasn't big enough. 4 and 13. Trying to erase this a little bit. There you go. Okay, so now we recorded on the table, and we drew a graph, and now we have to explain how the graph represents the pattern. So from there, what we have to do is we say that it increases by 1, right? It increases by 1, and then it goes up by 3. Okay, so we can have a little sentence here. I'm just trying to get my type ready. Text box. Right? So explain how the graph represents. Sorry, you just got to go back to the last slide, make sure my phrasing right. So as the input increases by 1. So remember, the input is also the x. The output increases by 3. And we can represent that visually, right? We can actually see that. It moves 1 to the right, up 3. And that happens for all of these ones. So remember to say if it's a pattern, it has to have these exact same coordinates. Sorry, not coordinates, but pattern rule every single time. That's why some of our pattern rules right now aren't actually working. And you're not getting full marks on the test. So let's change this color so it's hopefully a little better for that you remember that I added it. All right, so that's practice number 1. This is practice number 2. If you understand it at this point, here's the homework. You can get started. If not, here's one more example we can kind of explain and go over. So first of all, you're going to graph the data on the table. So remember, this becomes our coordinates. Oh, I don't want to change the color. Oh, I want to draw. Hello, can I draw? Why can't I draw? Oh, brother. Oh, brother. Technological issues. There we go. Okay, so this becomes our coordinates 1 and 11. Now, I use scale here because well, A, it helps us, but B, also because this picture I found wasn't big enough to go all the way up to 19. So when you're figuring out your scale, always start with your smallest number, which is 11, and your highest number, which is 9, or 1 and 5, and make sure that you can kind of figure it out from there. I always work a little bit backwards. Remember, 1, so you start at 0, move to the right, 1. Your second coordinate is 11, which means you're going up 11. As you notice, there is no 11 line perfectly, which means 11 will fall between 12 and 10. Okay, so it's going to fall right about here. That would be our very first coordinate because 11 is right here. Okay, and this is going to happen for all these. So you're going to go to 2, you're going to go to 13, right? 3 and 15, 4 and 17, and 5 and 19. Then it's going to ask us to describe the relationship. So once again, you move over, you're adding 1, and this is where it goes tricky. So you start at 11, and you're going to 13. We know this is 13 because it falls perfectly between 12 and 14. Okay? Which means we're going up 2. And you can repeat this process to see if it works out precisely, but I'm telling you right now. So you're going to insert I'm going to get my text box. I'm going to put it here. As the input increases by 1, the output increases by 2. I'm going to change the color again. I don't know if it matters to you, but it matters to me. All right, now this is kind of the extension from that. How can we write an expression to represent the pattern? Okay, how can we write an expression to represent the pattern? Now we're going back to using variables. Now, some things that we struggled with before is we were putting, we were saying an expression will be like x minus 1 equals 5. An expression doesn't have an equal sign. An expression is just this right here. So let's find a variable that's not x or y. All right, and then what we're going to do is we're going to find the relationship between these numbers. Okay? So what I always do, right, is always say that if it's increasing, because we know it's going from 1 to 11, right, we know it's going to be multiplication or addition. Okay, so we can say we're adding 10, but that's not going to be it. All right? So we just got to do a little thinking here. We could say it's times by 5, but that's not going to be right either, because all of these won't work. We could say it's times by 6. I'm going to get back to you. This is the problem, is sometimes I need to figure these out too, but you're going to see the expression on this before I upload it. All right? Next thing you need to do though is just let's go to D for now, is find the output when the input is 8. So remember, this line right here, this is our input. And how we can just find out what the output would be is just continue this pattern by going over 1 and up 2. And we can keep doing this, depending on the size of our graph, right? We can keep doing this until we get to 8. Now obviously I didn't make my graph quite big enough, but that will work, right? Or you can just simply, put it in your expression, which is what I recommend personally. Right? You can say, I put it in the expression. Okay? And you can use the exact same strategy to find out what the output is when the input. Absolutely. Because remember, input will be our variable. Our input is our variable in our expression. Okay? So once again, sorry I couldn't figure this out right on the fly. I should have did a little bit more pre-planning. I could sit here awkwardly in silence, but that's not necessarily going to help you at all. All right? Either way, I hope that you found this video somewhat helpful. There is the video at the top to help explain it. This is all your homework is for today. Make sure you review your homework from the other day so you're understanding everything properly. That's all I got for you. All right? Have a good day.